Today we're going to talk about solving systems algebraically, and there are two methods that you can use. The first method is substitution. Alright, so basically when you have a system of equations, it means that you have two or more equations in one problem. Okay? And we've already looked at solving systems using graphing, right? Because that was where we had to graph everything, and then we had to see where they intersect, because that was our solution, right? But now we're going to do it without graphing. We use all algebra. So this is how you do it, okay? In a system, we're going to have these two solutions. We have one, we have two, right? A says choose one of the equations and choose one variable that you want to solve for. You either want to make it x equals or y equals. So if you look at this, you want to pick the one that has like just x or just y, right? Because those are easier to solve. So with this one, I'm going to choose the first equation. X minus y equals 3. Okay? And then it says choose one variable to solve for. I know you guys are partial to solving for y. Make it y equals. But you know what? The y has a negative y. So I'm going to choose x. I'm going to solve for x. You see what I'm saying there? If I choose to get negative y, then I have to divide everything by negative. It's just an extra step. So if I solve this guy for x, that means I need to add the y. And then I have x equals 3 plus y. And this guy. Yeah? Okay? Now, the next thing you do is you plug this into the other equation. Because you can't plug it into itself. You gotta plug it into the other one. So the other equation was this guy, 7x minus y equals negative 3. Do you agree?
So that goes 7 times 3 plus y minus y equals negative 3?
Yeah. So then this x, the one that I just highlighted, is going to get substituted with 3 plus y.
Solve for y.
7 minus y equals negative 3. Now I'm going to plug in 3 plus y for that x. Yeah? And then what do I do, guys? How do I solve this? Distribute. Good. So let's distribute this. So then I have 21 plus 7y minus y equals negative 3. Yeah? Now you need to combine like terms. What are the like terms here?
The y.
Yeah, 7y minus y. What is 7y minus y?
7y squared.
6y. Remember, you're not multiplying. You're just doing 7 minus 1, right? So then that's 21 plus 6y equals negative 3. Do you agree?
Then you take the 21 into the back.
Good. We're solving for y, so minus the 21. Then you have 6y equals negative 24. And then what? Divide by 6. Y equals negative 4. Okay? Alright. So it's like I'm talking to you. Look at C. You solve for one of the variables. Good job. Now, plug that guy in to any of the original equations, and then let's solve for the other variable. Because if you look at your original, don't you have an x and a y? But since you found y, now you can solve for x, right? So when you go back and you plug it into any of the original equations, pick the easier one. I'm going to choose the first one. X minus y equals 3. But instead of this y, what am I going to plug in? Negative 4. So x minus negative 4 equals 3. What's a minus minus? Yeah, x plus 4 equals 3. So now what? Subtract the 4. So x equals negative 1, right?
Y equals negative 4. So then you put that in the order pair, right?
Good. So the thing is with this, guys, if we were graphing, this is the intersection at x comma y. Yeah? Remember to write your answer as an ordered pair. So negative 1, negative 4, right? Did I do that right? Did I mix up the order? Yeah. Right? You have to give me the ordered pair. If you were to graph the system of equations, this would be the what? I just said it. Intersection. Okay? So number 1 says find the intersection point or points of the following equations using substitution. So number 1, alright, this is nice because choose an equation, choose a variable to solve for, right? But the second one, look at that, it's already solved for me. It's y equals 3, right? So what I'm going to do is I'm going to take the other equation, 2x plus y equals 7. But instead of the y, we're going to substitute what? 3, right? Because y equals 3. Okay, so then plug that 3 in for the other y. Does that make sense? So now 2x plus y equals 7, which is 3, right? So let's solve for x. Minus the 3.
We're switching 2x equals 4.
2x equals 4.
Divide that by 2.
Divided by 2.
Because of that, you get x equals 4.
And then you get x equals 2.
So then you put that big line.
No, you don't even have to. Do I need to solve for y? What did they already tell me?
Probably did.
They already told me y equals 3. Right? I want you guys to see one where they actually gave you part of the answer because you do so many where you have to do so much work. When you see one that's a little bit easier, when you freak out, you don't know what to do. Okay? So then this one, the intersection is 2, 3. Yeah? No graphing. Okay? It's all algebra. So let's look at number 2. Number 2, I want you guys to write down something here. If your equations, alright, if they equal the same variable, okay? If your equations are equal to the same variable, then they are equal to each other. Alright? So if they're both y equals, or if they're both x equals, or in this case, if they're both x squared equals. Yeah? Give me a sharpie. Sharpen your pencil. What are they doing out there?
probably coming to school late.
Alright, so if you look, x squared equals 8y. Yeah? But the other one also says x squared equals something. Well then, they're both equal to x squareds? Yeah? Then they're equal to each other. You could plug this 8y in for that x squared. Couldn't you? It equals x squared. No, because 8y doesn't equal 2y. 8y equals x squared. So that means you could plug that guy into there. Okay? So since they're equal, they're both equal to the same variable. They're both equal to x squared. That means that they're equal to each other. So we could say 8y equals 2y plus 12.
And then you subtract this 12 and just solve it like a dollar.
You don't want to subtract the 12. You want to solve for y. So minus the 2y. Okay? So then you have 6y equals 12. Now what? Yeah, divide by 6. So then y equals 2. Alright, so y equals 2. Now, you're going to plug in this y equals 2 into one of your original equations. Which one do you want to plug it into? The first one or the second one? Okay, first one. So, x squared equals 8y. We just solved for what? Y. So, x squared equals 8 times y, which is 2. What is 8 times 2? Okay, so x squared equals 16. Wait a minute. You know what to do to get rid of that square? Square root. Good. But hold on. When I draw the square root, plus or minus. So x equals plus or minus. What's the square root of 16? 4. All right.
Plus or minus 4 comments there.
Oh my goodness. So think about what this means, guys. How many x numbers did we just find? 2. So when I go to write my solution, there are 2 of them. I have a positive 4 and I have a negative 4. And what is my y for both of them? 2. So 4, 2, and negative 2. You see that? See what we're doing? Okay, let's go on to the next one. Let's look at this guy, number 3. Alright, I have x plus y equals 6, and then this longer one that doesn't have any x's or y's all by itself. Which equation am I going to choose? First one or the second one? First, because you need to solve for either x equals or y equals. And the first one's a lot easier because it's just x and just y, okay? So, I'm going to choose this first one, x plus y equals 6. Which one do we want to solve for? Solve for x or y? Doesn't matter, you guys can choose. X, okay, so let's solve for x then. Let's minus the y, right? So then now I have x equals 6 minus y. Yeah? And then you're going to take this x equals and plug it into the other equation. So my other equation is 3x plus 3y equals 18. But instead of this x, I'm going to plug in 6 minus y. Times 6 minus y plus 3y equals 18. Now distribute, right? What's 3 times 6? 18. 3 times negative y, negative 3y, plus 3y equals 18. Combine like terms, guys. What happens? What cancels? Yeah. Good. The negative 3y plus 3y, it cancels the y's out. Wait a minute, so then my variable disappears? But what am I left with? 18 equals 18, right? You didn't do anything wrong. We didn't do anything wrong. I'm just going to tell you how to read this. Does 18 equal 18? Yeah. This is true, right? So, if this is true, there are no variables left. You know what this means? It means that this line, the first line and the second line, is basically the same line. What does that tell me about the number of solutions? Infinite. If it's true, then it's an infinite number of solutions. Now, what if this equals negative 18 equals 18? What if it was false? Then what does that tell me about the solutions? Well, but what does it mean if I got something that's false, like 5 equals 0? What would you tell me about the solutions there? Is it true? No, so then that means what? What about the solutions?
There's either y or 0.
No solutions.
There's no solutions.
Okay. All right, let's look at number 4. Number 4, which variable do you want to solve for? And in which one? The first equation or the second one? First, yeah. First one, what do you want to solve for that y? Get the y all by itself. Yeah. Because the other ones have a number in front. You don't want to solve for the x because that's an x squared, and no, right? So y minus x squared plus 2x equals 4. Okay? If I want to get this y all by itself, I need to move this x squared. Add the x squared. Subtract the 2x. Good. And do that on both sides. Add x squared minus 2x. Okay? So then now I have y equals, I'm going to put it in order. X squared minus 2x plus 4. I like putting things in standard form. I know this is a longer problem. Still follows the same principles, right? Y equals all of this. We're going to plug this into the other equation, right? So the other equation has 3y minus 3x squared plus 6x equals 10. Yeah? But I need to plug all of this in for the y. 3 times, what is this, x squared minus 2x plus 4 plus, oh no, sorry, I left out. Minus 3x squared plus 6x equals 10, right? All I do is just plug it in for the y. Now distribute. So 3x squared minus 6x plus 12 minus 3x squared plus 6x equals 10. I know this looks like a long problem, but I promise you, it's not as hard as it looks. What happens here? Yeah, look at this, 3x squared and the negative 3x squared, they cancel. The negative 6x, positive 6x, they cancel. 12 does not equal 10, right? Since this is false, what did we say that it means about the solutions? No solutions. Huh? I know. All that work for no solution. Are we okay with that? Alright. I believe we can do one more problem. Alright, let's do this one. Number 5. Number 5. Which one do you want to solve for? The first one or the second one? First one? Okay. Yeah? Okay. Alright, let's solve for the first one. What do you want to solve for? X squared minus y equals 5. What do you want to solve for? You gotta solve for y. Right? Alright, so then subtract x squared. Then you have negative y equals negative x squared plus 5. Guys, do we ever leave this as a negative y? No, so what do I need to do? Good, divide everybody by negative 1. So then we have y equals x squared minus 5. Yeah? Take this one and plug it in to the other equation. Plug it in for the y. So the other one I have is negative 3x plus y equals negative 7. But I need to plug all of this in for that y. So negative 3x plus, and guys, I'm not going to put parentheses around this y because I have x squared minus 5. And that's just it, right? So plus x squared minus 5 equals negative 7. Are we okay with this? What is it starting to look like? Christmas. Trinomial. It's just not in order. Let's put it in order. X squared minus 3x minus 5 equals negative 7. Starting to look like a trinomial. Guys, if it's a trinomial, the only way, well, not the only way, but the easiest way is to solve by factoring. We've got to make it equal to 0. I know, more factoring. What's going on? X squared minus 3x plus 2 equals 0. Actually, I'm going to put that up there. Alright? Alright. So then this is AM. Guys, what are two numbers that multiply to give me 2 and add to give me negative 3? Good. Negative 2 and negative 1. Since this is just a plain old x squared, you can go straight into your double parentheses. I mean, you could use grouping, but it's just a plain old x squared. X what? Minus 2 and x minus 1. Oh look, now I can solve for my x's because I can do my mini equations. X minus 2 equals 0 and x minus 1 equals 0. So x equals what? 2. What does the x equal over here? 1. Oh, so look at that. I have 2 x's already. So, you know what? Just keep your work organized. Okay?
Is that it?
No. You have to put them in ordered pair. So you have x equals 2 and x equals 1. But for each of these x's, you have to find their matching y's. How do I go and find their matching y's? Plug it into one of the original equations. Which one do you want to plug it into? First one or the second one? First. Okay. So So the first one is x squared minus y equals 5, right? You know x, that 2, so plug it in. 2 squared minus y equals 5. What's 2 squared? So 4 minus y equals 5. Subtract the 4, and then you have negative y equals 1. Do I leave it as a negative y? No, never. Divided by negative 1. What's 1 divided by negative 1? Negative 1. So when your x equals 2, your y is negative 1. Okay? So let's try the same thing for x equals 1. You want to plug it into the first one again, or you want to plug it into the second one? Okay. So the first one is x squared minus y equals 5. Now plug in your 1 squared minus y equals 5. I know you're not packing up. Don't you pack up? What's 1 squared? 1 minus y equals 5. Subtract the 1, then you have negative y equals 4. Divide by negative 1, and you have 4 equals a negative 4. Or y equals a negative 4. So these are your solutions up here, okay?
Okay.